in this video, I want to discuss what happens or what does it mean if a exponent is negative, and what does it mean if an exponent is 0. Okay, now let me make something clear. When we decide, or when a lot of times in math, when we say, this means this or this means that, people decided those. It's not like God came down and said, here's how you're gonna do math. So people eventually, at some point in history, they had to vote and decide, what do we all agree it means if you raise something to the 0 power, and what does it mean if you have something to the negative power? All right, a lot of people don't know that. They think somehow math comes from God, and it's up to us to understand God's thoughts. Okay, it's not that way at all. It was just people that decided what looks good, what works well. All right, so your question should really be, by the way, the answer to this is 1, and the answer to the second one is, it's going to be like that. And so the punchline, if you will, is that anything raised to the 0 is going to give you 1, except for 0. So 0 to the 0 is a little bit dicey. People haven't quite decided what 0 to the 0 means. So as long as you don't have that case, it's 1. All right. And then if you have something to the some negative number, that's the same as 1 over the positive version of that number. All right. And once again, it turns out we all know you can't divide by 0. So once again, except x equals 0. That's the only one that's problematic. Okay? All right, so the question should be, why are these good choices? Okay? Why does having something to the 0 power equal 1? Sometimes people say, well, maybe it would make sense to have x to the 0 equals 0, because after all, you're not multiplying anything together, right? Okay, and that's a valid point, and it's good to ask questions like that to understand why people chose what they did. Let me now make a case for both of these. Okay, so let me erase the purple. And we also want all the rules to mesh together. In other words, we don't want the rules to conflict with each other. We want harmony, so to speak, right? Okay, let's take a trip down memory lane. Remember when we said this rule, that if on the last video, if I had a quotient, we called it the quotient rule, and we said that when we have a quotient, we subtract, right? It's the exponents. All right, now imagine that I had x to the a over x to the a. Okay, that the quotient rule would suggest that that's equal to x to the a minus a, which is x to the 0. All right, now we haven't defined a 0 exponent yet, but let's follow this train of thought. Okay, on the left we have something divided by the same thing, right? Remember in grade school when we learned that anything divided by itself is 1, right? So like 5 over 5 is 1, 10 over 10 is 1, pi over pi is 1. You get the point. Okay? So that's a good argument for why we should all agree that anything to the 0 power is 1. All right? That's how that works. Okay? Now, a similar line of thought is going to explain the second one also. Okay, so this time let's assume that b is smaller than, or b is bigger than a. So maybe a number would be a better way to go. So 4 to the 3 divided by 4 to the 7. Okay, now according to the quotient rule would suggest that this is equal to 4 to the minus 4, right? Okay, now forget about exponents for a second. Let's rewrite the original. I'll put it in a purple circle. Let's rewrite it as repeated multiplication. So you have 3 4s on top. You have 7 4s on bottom. So forgetting about exponents, you would probably just cancel. Okay, and what would you get? You would get 1 over 4 to the 4. Okay, so that's a good argument for saying that 4 to the minus 4 is equal to 4 to the 4. Okay, now if you can do this with lots of different powers, lots of different numbers, and you will see that the pattern on the right, where x to a negative number, it'll make sense. It'll mesh with the previous exponent rules to have that equal to 1 over x to the positive version of that number for the absolute value. All right.